In this short lesson, we will not try to compute the huge number 3 to the power of 2026 plus 5 to the power of 2026. Instead, we will extract powerful facts about it, whether it is even its last digit, sum divisibility, and roughly how many digits it has. First, is it even or odd? For any even exponent, an odd base raised to that exponent stays odd. So 3 to an even power is odd, and 5 to an even power is odd. Odd plus odd equals even. So the sum is even. Now, is it divisible by 4 or 8? We check remainders. Modulo 4, 3 behaves like -1, and 5 behaves like +1. With an even exponent, -1 squared many times becomes 1, and 1 to any power is 1. So each term is 1 modulo 4, and the sum is 2 modulo 4. That means it is not divisible by 4. Modulo 8, both 3 squared and 5 squared are 1. Raising that to the power 1013 still gives 1. So each term is 1 modulo 8, and the sum is 2 modulo 8. That means it is divisible by 2, but not by 4 or 8. Next, the last digit. For powers of 3, the last digit repeats every 4. 3, 9, 7, 1, and then it repeats. For powers of 5, the last digit is always 5. We only need the remainder when dividing the exponent by 4 to know where we are in the cycle for 3. 2026 divided by 4 leaves remainder 2. That lands on 9 in the cycle, so 3 to the power of 2026 ends in 9. 5 to the power of 2026 ends in 5. 9 plus 5 ends with 4, so the whole sum ends with digit 4. Quick checks for divisibility by 3 and by 5. Modulo 3, 5 behaves like -1. With an even exponent, that becomes +1. 3 to a positive exponent is divisible by 3, so it is 0 modulo 3, and the sum is 1 modulo 3. Not divisible by 3. Modulo 5, 3 behaves like -2. With an even exponent, that gives 4. 5 to a positive exponent is divisible by 5, so it is 0 modulo 5, and the sum is 4 modulo 5. Not divisible by 5. Finally, how big is it? The number of digits of a positive integer is the floor of log base 10 of the number plus 1. The largest term dominates the size, so we can use 5 to the power of 2026. The digits of 5 to the power of 2026 equal the floor of 2026 times log base 10 of 5 plus 1. That is about 1416.1. So the digits count is 1417. Adding the smaller 3 to the power of 2026 does not change the digit count, so the sum also has 1417 digits. Summary: it is even, not divisible by 4 or 8, not divisible by 3 or 5, and its last digit is 4. It has 1417 digits. These facts were found without computing the number itself, by using modular arithmetic and logarithms.